So let's start with a basic question. Before we actually start, this is right out of the CLEP college algebra. So in your notebooks, guys, if you just want to do this, we'll do this together just as a quick warm-up. So 3 minus 5b squared. And the idea with this problem is, so again, this is a college algebra question. The idea is that you should be able to look at it and basically FOIL, right? So when we FOIL, we write it out twice. So 3 minus 5b, 3 minus 5b. And when we FOIL that, we're basically multiplying this times that, this times that, this times that, and this times that. So the other way people do it is they can do like a Punnett square, if you think of it that way. And this will have 3 and minus 5b, and this is 3 and minus 5b. So these two will multiply and give us 9. These two will multiply and give us negative 15b. These two will multiply and give us negative 15b. Those two will multiply and give us 25b squared. So basically, we write out all these, and it becomes 9 minus 15b minus 15b, and then plus 25b squared. So when we do that, we get 9 minus 30b plus 25b squared. That would be the answer to that question. And that is the first question in the CLEP College Algebra list of questions. We're going to transition into the next one, but that's the first question. And it starts off with, these are called binomials. A binomial, if you think of it as two terms. And so we have a binomial multiplying a binomial, which will just multiply and give us this answer, 9 minus 30b plus 25b squared. One of the best ways to study for any standardized test is just to do a lot of practice of the past questions of that test, and that's what we'll be doing. So let's look at a few more questions that are related to polynomials, rational expressions, and complex fractions as it relates to the CLEP test. Number 2. Which of the following is a factor of, and then they give us the question. The question is 4 minus, okay, so that's what they gave us. Now this question is actually very brilliant. It's brilliant because, again, one of the things that helps anybody become very good at math is that they can recognize patterns. And if you can recognize patterns, then you can excel in math, right? So within that, notice there's a trend here. Notice there's a trend in the squares, right? There's square and a square there. But we talked about this yesterday, the idea of the difference of two squares. And with the difference of two squares, no matter what A is or what B is, you just write it like that. So basically you take the first value, so A plus B, A minus B, right? And so when you do that, you basically get whatever your A is, you substitute it in, or let's actually do it over here. You substitute it in, and whatever your B is, you substitute it here. Right? So we have 2 minus x plus y, because your B is x plus y. That's really what it comes down to. This whole thing here is like your B. This whole thing here is like your A. You see, in math, there's no tricks at this level, right? There's really no tricks. If this says a squared minus b squared is the difference of two squares, then that's your A and that's your B. And you just plug it down into the formula. And this is A minus B. And now we have to do A plus B. So we just write the same thing, A plus x plus y. That's the answer to that problem. Those are the two factors of this problem. It's a beautiful question because it's a difference of two squares given in the form of that problem. Okay, now let's do an interesting one with the difference of two squares and a complex fraction. So if we have a complex fraction like x squared minus 9 divided by x plus 2 divided by x minus 3 over x minus 2. Remember we talked about complex fractions before. With complex fractions, the idea is, imagine if you have A over B over C over D, right? So we have this level, one level over one level here, divided by one level there over another level. So if it's A over B divided by C over D, then that becomes A over B times D over C, right? So if you take it that way, this over here can be rewritten, if you want to rewrite it, as x squared minus 9 divided by x plus 2 times x minus 2 over x minus 3. So we can write it that way. We can basically, we've written it as A over B times D over C, right? If we assign each of these a letter. So one of the skills in math is knowing how to assign different things assigning things and using them appropriately and then putting them back in the form they need to be. But I assigned this as A, B, C, and D. And then I did this step, which is your fraction arithmetic, A over B divided by C over D. And then I flip that around, which is what happens with our fraction division. And then we come over here. At this point, though, in order to do this, this is a rational expression problem, right? So this is like rational expressions or rational functions. We're doing multiplication and division of rational expressions. What do I do at this point? I need to factor every single one of these. If they're not in their factored state, then I need to factor them. X squared minus 9 can be factored. It becomes x plus 3, x minus 3, divided by x plus 2 times x minus 2 over x plus 3. This is what I've told us about before. The beauty of being able to cancel terms that are the same is a wonderful thing. And so we're going to cancel those out. We get x minus 3 over x plus 2 times x minus 2 there. And our final answer would just be x minus 3, x minus 2 divided by x plus 2. So that's how we work out these problems. They all have something in common. We have polynomials, whether we're multiplying polynomials or we're factoring polynomials with the difference of two squares, or we're working out with rational expressions. That's what we've done, and complex fractions. If you have any questions on these concepts, let me know. But it's always good to know what topic you're working on specifically, and then find videos or notes or PDFs on that topic. So let me know if you have questions, and have a blessed day.